Evaluation of sine to the power nx into dx, limits running from 0 to pi by 2. To evaluate, let us consider this whole term into in. Therefore, in is equal to 0 to pi by 2 sine to the power nx into dx. We have already proved that reduction formula for sine to the power integration of sine to the power nx into dx is equal to this one. This one we already proved, isn't it? See, applying the limits to this formula, applying the limits 0 to pi by 2 to this formula, here the second term, this is the first term and this one is the second term. Second term is constant term. We cannot apply lower limits and upper limits for this. So, we can write it as it is. Next, here, see here, applying upper limit, here cos pi by 2 is there in the numerator. Applying upper limit, cos pi by 2 value is 0. 0 into this number, any number is 0. Applying upper limit, we get 0 minus of lower limit. Lower limit here, sin is there in the numerator. Sin 0, its value is 0. 0 into any number is 0. So, applying upper limit and lower limit, this whole term becomes 0. We left with only n minus 1 divided by n into in minus 2. Therefore, in is equal to. So, we obtained the value of in when in minus 2 is known. Now, to find the value of in minus 2, we put n is equal to n minus 2 in in. So, here putting n is equal to n minus 2 in in, we get this one. In minus 2 is equal to n minus 3 divided by n into in minus 4. Here, next, to find the value of in minus 4, substitute n is equal to n minus 4 here, then you will get n minus 5 divided by n minus 4 into in minus 6. To find the value of in minus 6, again put n is equal to n minus 6 in this formula, you will get in minus 6, that is n minus 7 divided by n minus 6 into in minus 8. Here, if you want next term, in minus 8 means substitute n is equal to n minus 8 in this formula, then you will get in minus 8. If you continue in this way, it ends up with two results, one for odd numbers and other for even numbers, because I already told that here n is a positive integer and this positive integer contains positive odd numbers as well as positive even numbers. So it ends with I3 when n is odd and it ends with I2 when n is even. Okay, now combining all these values in this formula, we get here in is equal to n minus 1 divided by n into in minus 2. Substitute the value of in minus 2 here. Substituting, you will get this one. Next, we want in minus 4. Again, substitute in minus 4 in this formula. Continuing this way, in the last, you will get this equation 2 by 3. It ends with 2 by 3 I1 when n is odd number, and it ends with 1 by 2 into I0 means I0 when n is even number. Now let us find out I1 and I0 values. Here I0 means I0. Put n is equal to 0 here. See here I0, this is equal to 0 to pi by 2 sine to the power 0 x into dx, isn't it? 0 to pi by 2 sine to the power 0 x, 0 into x is equal to 1. Sine anything to the power 0 except 0, its value is 1 into dx. Now integrate this one. Integration of constant is x. Applying upper limit and lower limit, you will get pi by 2 minus 0 is equal to pi by 2. Now to find the value of I1, put n is equal to 1 to this one. I1 is equal to 0 to pi by 2 sine to the power 1 x into dx. Sin to the power 1x is same as sin x is equal to 0 to pi by 2. Sin x integration is minus cos x. Applying upper and lower limits, you will get 1, isn't it? Now substituting the values of I0 and I1 in this one, you will get I0 value is pi by 2, I1 value is 1. So this is the formula which you have to keep in your mind.